If you're about to choose between Databricks and Snowflake, stop. Don't make the decision based on a vendor demo, blog post, or what your last company has used. In this video, I'll give you a framework that actually holds up. Because I've seen this go wrong too many times, pipelines breaking 6 months in, cloud bills spiraling out of control, engineers spending more time firefighting the platform than actually building things. And the worst part, it's completely avoidable. Today, we are covering the real architecture, the real trade-off, and some dead simple analogies to make it all stick together. So you make this decision once and get it right. So let's go. First, a little context. A few years ago, these two tools had completely different jobs. Snowflake was your cloud data warehouse, the place where your data live, and your analysts ran SQL queries for reports and dashboards. Clean, structured, and no fuss. Whereas Databricks was your data engineering and ML platform where engineers ran Spark jobs, built complex ETL pipelines, and data scientists trained machine learning models, which was more of a heavy lifting. Different tools, different jobs, no overlap, which was easy. But both platforms got ambitious. Snowflake now has Cortex AI, Snowpark, and streaming ingestion coming straight for the engineering space. Whereas Databricks has SQL Warehouse, Agentbricks, and Unity Catalog coming straight for the analytical space. They are now direct competitors, and that's exactly why this decision got so much harder. So let's break it down the right way. Everything starts with architecture. Think of it as a foundation. Get this wrong and everything built on top of it wobbles. Snowflake is like renting a fully furnished, professionally managed apartment. You show up, everything's set up for you, you just live your life. The landlord, which is Snowflake, handles all the maintenance, upgrades, and optimization behind the scenes. There are 3 layers: storage, compute, and services. Your data lives in Snowflake's proprietary columnar storage. When you run a query, virtual warehouses spin up on the demand, do the work, then auto-suspend when they are done, so you're not paying for idle compute. The services layer handles metadata, query optimization, concurrency, all automatically. You never touch a wrench, it just works. The trade-off, it's their building, their format, their roadmap. You're trusting Snowflake to build what you need and when you need it. Whereas Databricks is like buying your own house. You own it, you can renovate it, expand it, wire it however you want, and critically, your data lives on your cloud storage, which is like Amazon S3, Azure Data Lake Storage, Google Cloud Storage, whatever you're already running. That's the Lakehouse architecture powered by Delta Lake, an open table format that gives you asset transaction, schema evaluation, and time travel on top of your own storage. Compute runs on Apache Spark clusters or Photon-powered SQL warehouses. And Unity Catalog governs everything from raw data to deployed ML models. Your data stays in open format, no proprietary lock-in. Any tool that reads Delta Lake or Parkway can access it. The trade-off, you've got more to manage, more infrastructure decisions, more configurations, more operational surface area. So the first question is very simple. Do you want the managed apartment or the house you own? Architecture is a 3-year decision. Be honest about which one you actually need. The next comes the technical fit. There are 6 dimensions, so let's see one by one. The first one is SQL analytics and BI concurrency. Think of Snowflake's multi-cluster architecture like a highway that automatically adds lanes when traffic picks up. Dozens of analysts hitting dashboards simultaneously, it scales without breaking a sweat. Whereas Databricks SQL warehouses powered by Photon Engine are genuinely closing the gap, but for pure BI concurrency, Snowflake is the gold standard. Number 2, data engineering and ETL. If Snowflake is the highway, Databricks is the full logistics network, like trucks, warehouses, sorting facilities, the works, which is equivalent to complex pipelines, semi-structured data, multi-stage transformation. Databricks gives engineers Delta Live tables, autoloaders, and Medallion architecture as first-class tools. Whereas Snowflake Stars and Stream handle SQL-based pipelines well, but push beyond that, and you're bolting on the external tools. So clearly, Databricks wins here. Number 3, machine learning and AI. Databricks is basically a purpose-built ML operations platform, ML flow for experiments, tracking, feature stores, model serving endpoints, vector search for RAG applications, notebooks in Python, Scala, and R. The full ML ops lifecycle is native. Snowflake's Cortex AI is genuinely solid and improving fast, but if you're a data scientist or iterating on the models daily, Databricks is their natural home. Number 4, streaming and real-time. Need data updated by the second, live fraud detection, real-time recommendations, event-driven pipelines. Databricks structured streaming on Spark is battle-tested at massive scale. Think of it like a river that flows continuously. Snowflake's Snowpipe and streams handle near real-time ingestions well, more like a canal with the control logs. Great for many use cases, but for true low latency or complex event processing, you want River, which is Databricks. Next comes governance and security. Snowflake's row-level security, dynamic data masking, and horizon catalog are mature and fast to stand up, like a security system that comes pre-installed and pre-configured. Whereas Databricks Unity Catalog spans both data asserts and ML asserts in one unified governance layer, which is more powerful, but you have to install and wire it yourself. Need governance running fast with minimal setup? Then go for Snowflake. Governing a full data and ML ecosystem long-term, Unity Catalog is worth the investment. Next comes vendor lock-in. With Databricks, your data is in Delta Lake on open cloud storage, like keeping your files in standard formats on hard drive you won't. Swap out tools, add new ones, migrate if you need to. Whereas Snowflake has made a real progress with Iceberg support and open catalog, but the core storage is still proprietary. If data portability is a strategic requirement for your organization, Databricks is the cleaner answer. Now let's see the business perspective. There are 3 factors that often determine whether the whole thing succeeds or fails. The first one is team composition, the most underrated factor in this entire decision. Snowflake is like handing someone a really powerful calculator. If your team lives in SQL, analysts, BI developers, analytics engineer, they are protective on day one. Low learning curve, high time to value. Whereas Databricks is more like handing someone a full engineering workbench. Powerful, flexible, capable of incredible things, but you need people who know how to use it. Python, Spark, distributed computing, notebook-driven workflows. If that skill set isn't already on your team, budget seriously for the ramp-up time. The best platform in the world is useless if your team cannot operate it. The next comes cost model, and this one trips people up. Neither platform is inherently cheaper. It depends entirely on your workload pattern. Snowflake bills per seconds of virtual warehouse compute, bursty, unpredictable workloads with lot of idle time. Auto-suspend makes this genuinely efficient. You only pay when the engines are running. Think of it like paying for a taxi. You pay per trip, nothing when you're not riding. Whereas Databricks uses DBU pricing, which is Databricks units, which varies by workload tier and cluster type. Better for sustained long-running pipelines and ML training when it's well-tuned. More like leasing a car, better value if you're driving constantly, but the pricing model is more complex and needs active monitoring. But here's the real trap. The total cost of ownership isn't just the platform bill, it's the platform spend plus engineering hours to manage it, plus operational overhead, plus migration cost if you pick the wrong one. Snowflake's simplicity saves ops hours. Databricks flexibility costs upfront platform engineering. Model all 3 before you decide. Data maturity, where are you actually at? Early stage, SQL heavy team need time to value fast, which is Snowflake. Mid stage, analytics is covered, now building out ML and real-time use cases, Databricks or a hybrid model would work out. Advanced, running end-to-end AI workflow with large engineering team, Databricks becomes your center of gravity, and plenty of mature organizations run both Databricks as the engineering and ML backbone, Snowflake as a clean, governed analytics layer on top. That's not indecision, that's a proven real-world architecture. Answer these 5 questions honestly and you'll figure out which tool to use. Number 1, primary workload. SQL analytics and BI, go with Snowflakes. Data engineering, ML pipeline, streaming, go with Databricks. Number 2, primary user, analyst, BI developers, go with Snowflake. Data engineers, data scientists, go with Databricks. Number 3, ML ambition, predictive analytics through SQL is enough, Snowflake Cortex covers you fully. Full MLOps lifecycle, training, serving, monitoring, go with Databricks, no contest there. Number 4, how much does openness matter? Vendor lock-in is acceptable for operational simplicity, go with Snowflake. Open formats and data portability or your strategic requirement, go with Databricks. Number 5, data maturity. Early stage, moving fast, needs simplicity. Snowflake speed to value wins here. Scaling long term with a technical team, take Databricks seriously. If your answers are mostly Snowflake, go with that. If your answers are mostly Databricks, invest in Lakehouse. If it is a split, you are a hybrid candidate, and that's completely legitimate architecture. At the end of the day, this was never about which platform is better in some abstract sense. It's about fit to your workloads, your team skill, and where you want to be in the next 3 years. Get the fit right, and the platform choice becomes obvious. Next in Databricks series is the Workspace 2, so stay tuned.